Hi, my name is Donna Schmidt. I am a math teacher at Dubuque Senior High School. I teach 9th through 12th grade math. I've been teaching for 10 years. The activity started today by reviewing some information about linear functions, and then we moved on to a description of quadratic functions. The students had to recall from the past two forms of parabola, and we wrote those equations on the board. We looked at the general form of an equation, and then we examined the vertex form, and we talked about important characteristics of a parabola based on those two equations. Then I instructed the students that they would be working on a worksheet together in collaborative small groups, that they needed to make connections as they were working through the worksheet to help them figure out a new form of a quadratic equation called the factored form. As the students were in groups, I walked around and helped them make some of these connections that weren't as obvious and clear as I thought might have been presented on the worksheet. At the conclusion of this small group interaction, students had come up with the factored form, so the objective of them coming up with that was met. We looked at a real-life application problem. The problem had to do with finding the maximum area enclosed in a rectangular object. After this activity, we took out the CBR equipment, calculator-based rangers, which are motion detectors, and I had the students stand in front of the motion detector and jump and predict what the graph would look like. And then the students applied what they learned by taking the times from the jump heights and substituting those numbers into a formula from physics, Newton's motion formula, and they were able to calculate their jump height. And then after students did this, to assess their understanding, I had two examples of graphs on an overhead, and the students had to tell me what they could about those two students jumping. The final assignment was for them to take information away from them. That there was a question that I had asked them. There was a girl that jumped. She was a 5-year-old girl jumping in front of the motion detector, standing so many meters away from the CBR, and she had to jump out of the way, and they had to draw the sketch of that graph. So they were applying everything that they learned. The goal of this unit was to have students use technology, to use the TI Texas Instrument graphing calculators, and to use a calculator-based ranger to help them understand the concept of factoring and how that applies to the factored form of an equation. One of the objectives of the goals was to develop student awareness in the patterns that they could observe between the general form, the vertex form, and the factored form of an equation. The students were assessed on their understanding of the activity during my interaction with them during the small group discussion. I will also be assessing the information that they turned in on those worksheets to evaluate whether or not they understood the concepts that were being taught. I chose to use the graphing technology and the CBR because these are excellent tools to evaluate student understanding of mathematics. The graphing technology has many wonderful features to it. Not only can students graph, but in the video you should see students entering data into lists and analyzing those lists and seeing how the data affects the shape of the parabola. The CBR is an excellent tool to use. It's relatively inexpensive, and you're allowed to capture distance, acceleration, and velocity using one piece of technology. I've used other technologies in the past, and I've had to have extra cables and extra cords and extra devices attached to these detectors to get the graphs that I needed to. And as you could see in the video, all it requires is to download one program and then push a few buttons to get the motion detector to work. So relative ease has a big impact on the technology that I chose to use. I chose to put the students into small groups because it helps them to verbally explain their thinking when they're working in small groups. I think when they work with others, it increases their chances of understanding what's being presented when they're able to ask their peers other than coming to me and asking me for help all the time. They feel less intimidated when they're working with one another. Also, the technology sometimes doesn't work correctly like it should, and they feel very comfortable asking one another for help with the technology. The critical thinking component of the model, I think, can be observed in the video. You can observe student inquiry skills in the video. Students are observers during the data collection process, and they're also participants. When I move from whole group discussion to small group discussion, in their prearranged seats, they're better able to understand the math because of where they're sitting, how they're interacting with one another in those situations, in that seating arrangement. The seating arrangement allows them to more easily work with one another as opposed to being separated into the large group instruction. The information processing models that you're most likely to observe in the video is that of interpretation and evaluation. When students are asked to interpret information, to draw conclusions from what they've learned, to reflect on their thinking and to do some analyzing, there's quite a bit of information processing going on. They're better able to understand the purpose of modeling quadratic data after first having an appreciation of what it is that they're going to factor and why that they're factoring it. I had given the worksheet that I used at the beginning of class to other classes, and I designed the worksheet to try to get students to understand the importance of factoring. And I think my knowledge of quadratics and what it is that students need to learn and why that's important helped me to design the worksheet. I did make improvements on the worksheet the second time I had given it. First time I'd given it, I just asked them to do the same thing repeatedly, to factor it by hand, sketch it, and then list the x-intercepts. But understanding that students need to then apply what they've learned, I designed the worksheets so that they had to be given, at times, the x-intercepts and write the general form of the equation. So they had to apply what they were learning instead of doing the same thing repeatedly. There were times throughout the activity, especially the activity where students were out of their seats collecting data during the jumping experiment, where some of the students had indicated to me they didn't know what to do. And so I think it was important at that time that I stopped them, asked them to freeze, stop what they were doing, and explain to them what it was that they needed to do. Or redirect them, tell them to go back and talk to the reader and have the reader read the information, and then after reading it, then let them decide if they had enough information as to how to continue.